Greetings and welcome to this educational offering by Neurophysiology Enlightenment. Our brains are constantly active, processing information from our senses and sending commands to our muscles. This remarkable feat is accomplished by the nervous system, a complex network of specialized cells called neurons. Neurons communicate with each other using electrical and chemical signals. This communication happens incredibly fast, allowing us to react to our environment in real time. Imagine the nervous system as a vast network of roads connecting cities. Information travels along these roads as electrical signals. These signals are very fast, like cars speeding down a highway. This speed is crucial for our survival. When we touch something hot, our nerves send a pain signal to the brain. The brain then sends a signal back to our muscles, telling us to move our hand away. All of this happens in a split second, thanks to the rapid-fire communication of our neurons. This rapid communication wouldn't be possible without the action potential, a brief electrical pulse that travels down the neuron's axon. The axon is like a long cable that transmits the signal from one neuron to another. When a neuron receives a strong enough signal from other neurons, it triggers an action potential. Neurons communicate using a special language, the action potential. Imagine a line of dominoes. When you knock over the first domino, it sets off a chain reaction, toppling the rest. An action potential is similar. It's a brief electrical event that travels down the neuron's axon, like the falling dominoes. This electrical signal carries information from one neuron to another. The action potential is created by the movement of ions, which are electrically charged atoms, across the neuron's membrane. This movement of ions changes the electrical charge inside and outside the neuron, creating the electrical signal. Think of it like a battery, where the movement of electrons creates an electrical current. After a neuron fires an action potential, there's a brief period where it can't fire again, even if it receives a strong signal. This period is called the absolute refractory period. Imagine a camera flash. After it flashes, it takes a moment to recharge before it can flash again. The absolute refractory period is like the camera's recharge time. During this period, the neuron is basically resetting itself, like a computer rebooting. It needs this time to restore its internal balance of ions so it can fire another action potential when needed. This ensures that the neuron doesn't get overworked and can continue to function properly. Section 4. Unidirectional flow and firing control. The absolute refractory period plays a crucial role in how neurons communicate. Firstly, it ensures that action potentials travel in one direction only, preventing signals from bouncing back and forth. This unidirectional flow is essential for the orderly transmission of information in the nervous system. Secondly, it limits how often a neuron can fire. Imagine a car going downhill. Without brakes, it would quickly lose control. The absolute refractory period acts like brakes on neuronal firing, preventing them from firing too rapidly. This control is essential to prevent overstimulation and maintain the stability of the nervous system. Section 5. Clinical insights from the absolute refractory period. The absolute refractory period is not just a biological curiosity. It has significant clinical implications for understanding and diagnosing neurological disorders. Doctors and scientists use various techniques to study the electrical activity of the brain and nerves. For example, electroencephalography, or EEG, measures brain waves, while nerve conduction studies assess the speed of nerve impulses. The absolute refractory period influences the patterns seen in these tests, providing valuable information about the health of the nervous system. Understanding these patterns helps doctors diagnose conditions like epilepsy, multiple sclerosis, and nerve damage. We hope you found our educational offering valuable and informative. Your understanding of the absolute refractory period and its clinical applications is essential for advancing neurophysiology knowledge and practice. When you have completed all the content and videos, please scroll to the end to take the final test. Upon successful passing, you will receive 0.5 units of continuing education as recognition of your achievement. Thank you for your dedication to learning and for being a part of the NeuroEnlight community.